Hi, we meet again. So let's continue our lesson. After the introduction of confidence interval, we will have statistical analysis for one population mean. So we want to construct the confidence interval for one population mean, only one mu. So we have here the confidence interval, one population mean. We have two population mean, independent and dependent. Now we'll focus on this one population mean. Alright, so confidence interval for one population mean, so only one mu here. Okay, so estimate the confidence interval for the population mean when population variance and deviation is known, and estimate the sample size by using the concept of a confidence interval for the population mean. So in this course, we assume that all data comes from normal distribution. Okay, there are three formula that you have to know when you want to construct a confidence interval for one mu. The first formula is when the sigma square is known, you have to use the first formula. When the sigma square is unknown, you have to consider the sample size. When your sample size is greater than 30, you have to use this formula. When the sample size is less than 30, you have to use this formula. So this formula we have in your stat table, page 5. Okay, now let's look at the example, how to construct a confidence interval for one population mean. So let's look at how to solve this exercise and make sure you have your statistical table with you. Okay, example 5.1a. A lecturer from Center for Mathematical Sciences, UMP, had found that basic mathematics mark for diploma students tended to follow a normal distribution with standard deviation of 4. So sigma equals to 4. For a simple random sample of 10 students, sample size n equals to 10, the marks are as follows. So we have the data here. The question is, construct and interpret the 90% confidence interval for the population mean of basic mathematics marks. Interpret your answer. So that confidence level is 90% and they ask you to find the population mean. Okay, so we know that to estimate the population mean, one population mean, we have three formula. So which formula that we want to use? So go to your stat table, page 5. Look at the formula here, confidence interval for one mu. We have three formula. So which formula that we want to use? From the question, sigma equals to 4. Means that we know our sigma square equals to 16. So sigma square is known. Sigma square is known. Use formula number 1. So the formula we have minus and plus. So we simplify the formula. The formula is x bar plus minus z alpha over 2 sigma over square root n. Okay, look at the formula. We have to substitute all the values. Look at the formula. Do we have the x bar values? No, we don't have the x bar value, but we can find from the data. From the data given, we have to calculate the x bar. X bar is equals to 84.9. So we have the x bar now. We have the sigma equals to 4. We have the n equals to 10. Now we have to find what is z alpha over 2 values. How to find z alpha over 2 values? We can find from the given confidence level 90%. We calculate the alpha. Alpha is 0.1. So confidence interval, alpha need to be divided by 2. You will get 0.05. So z 0.05, we can find it in your stat table. So look at your stat table. Find table for percentage point of the normal distribution. Okay. Look at our alpha. Alpha is 0.05. So this one is the alpha. Find alpha 0.05. So we look at here, alpha is 0.05. And then look at the right here to the right, Z alpha is 1.6449. So Z 0.05 is equals to 1.6449. So let's get back to the solution. Z alpha 0.05 is 1.6449. So now we have all the values. Substitute into the formula. You will get 84.9 plus minus 1.6449 times sigma 4 divided by sample 10. Okay, press your calculator, do it this one first, and then you have your lower boundary 82.8194 and your upper boundary is 86.9807. Notice that the lower boundary must be smaller than the upper boundary. This is your A, this one is your B. Interpret your answer. So how to interpret? We are 90% confident that the population mean of marks lies between your lower boundary and upper boundary 82.8194 and 86.9807. So your mu is in between these two values. Anggaran. Okay, exercise 5.1a. A parking control officer is conducting an analysis of the amount time on parking meters. A quick survey of 15 cars, so n equals to 15. They have just left their meter parking spaces. Give the mean and standard deviation. So the mean is x bar because of the sample 18.1333 and the standard deviation 9.7531. Construct a 95% confidence interval. So confidence level 95%. Okay, so which formula did we want to use? We have the x, we have the x bar. So we have the x bar, we have the s. So n equals to 15. Sigma is unknown. N is less than 30. So third formula. So the third formula is x bar plus minus t alpha over 2 nu s over square root n. Alright, so now let's check the formula. Do we have the x bar? Yes. Do we have the s? Yes. Do we have the n? Yes. So we don't know this one. T alpha over 2? No. So from here, confidence level 95%. Alpha 0.05. Alpha over 2 0.025. Nu n minus 1. 15 minus 1 is 14. So t 0.025. 14. Get here. Here is your nu. Our nu is 14. And our alpha is 0.025. So the midpoint is here. 2.1448. So get back to the solution. Equals to 2.1448. Substitute all into the formula. X bar plus minus So when you simplify this one inside intercalculator, you will get for the lower boundary and the upper boundary. Okay, the interpretation. Okay, exercise 5.2a. I will leave it for you to try. So we will discuss which formula that you want to use. A consumer magazine has contacted a super random sample of 36 owners. So sample size is 36. As many defects, the average number of defects. So x bar is 3.7 with a standard deviation 1.8. Construct a 95% confidence interval. So confidence level 95%. Estimate the population mean using confidence interval. So which formula that we want to use? Can we use the first formula? Do we have the sigma square? No, we don't have. So we cannot use the first formula. So we have second formula and the third formula. Look at the sample size. Sample size here is n greater than 30. So use the second formula. Okay, you can try on your own here. So next exercise 5.3a. This exercise is different from previous exercise. A telephone company wants to investigate the mean number of minutes people in the city spend talking long distance with 90% confidence level. So confidence level 90% from past record. Okay, past records means that information is for population. And estimate of standard deviation is 12. So sigma equals to 12. What is the minimum sample size? The question asks you for this one. When the estimation error, so error is E, is less than 5. So the question do not ask you to construct the confidence interval. The question asks you to find the minimum sample size. You have to find the n. Okay. From the definition, probability x bar minus error less than mu less than x bar plus error equals to 1 minus alpha. From here, we know that x bar minus error, x bar plus error. Okay, look at the information given. Here we have the sigma. So we can use the first formula to construct the confidence interval, which is x bar plus minus z alpha over 2 sigma over square root n. When you want to construct the confidence interval, you have to use this formula. But now we want to find the sample size. So from the definition here, we know that this one is E, this one is your E, this one is E. Okay, E is equals to z alpha over 2 sigma over square root n. Formula here. Okay, from our information, E is less than 5. So the E, z alpha over 2 sigma over square root n is your E, is less than 5. This one is E, less than 5. So E less than 5. Z alpha over 2 sigma over square root n less than 5. Substitute all the information. Confidence level 90%, alpha is 0.1. Alpha over 2, 0.05. So Z 0.05 is 6449. Substitute all into the formula. So we will get n is greater than 15.5848. So n is 16.